aim was very similar to what was just being discussed. How can you diagnose? And what are all the pitfalls? We faced those pitfalls and decided that we would not stay in this domain for long. That is, healthcare becomes our POC domain, proof of concept domain. The technology again can be reused, but as the project proceeded, we figured out that this is not really an applicable area for us to work in. Okay. So what I will do here is one of the things that we value the most in this group effort is the development and the relation that the capability building that has happened with the partner institute. There are multiple components in this project, including automatic speech recognition, decision modeling, dialogue modeling, acoustic signal analysis, which was taken by the Bain Institute. What we will do is we will start with the acoustic modeling, curve analysis and how it integrates to our system, and what are the highlights of their part of the work, and we'll move on to the higher details, larger details of the project.
Thanks, Manish. And Narayana. So the focus which was given to us was acoustic signal analysis for healthcare, with a special emphasis being on the curve signal analysis. So based on the literature survey and as well as the multiple discussions we had with doctors, what we understand the problems are primarily at the high level these three: lack of accurate differentiated diagnosis of chronic respiratory diseases in the absence of detailed signal analysis, lack of cost-effective and lab-free methods for early diagnosis of CRDs, and the assessment of treatment efficacy. So these three being the primary problems, the objective we have set for ourselves is to develop an Internet of Things-based solution for respiratory digital health services. The system must use detailed of characteristics along with very few other symptoms with a rule-based engine in providing an early diagnosis or a recovery monitoring summary. And also develop the cuff and the V sound analysis using the machine learning algorithms. Yeah, this is the team we have. So these are the achievements. Last time we actually demonstrated the entire solution what we have. So the achievements are we successfully completed the proof of concept, integrating all the components. We have a fever sensor which is also integrated with our mobile to capture the body temperature. Earlier itself, we developed the mobile application to capture the symptoms and for collecting the acoustic samples. And we have a gateway controller which actually does the event extraction and detailed cuff characteristics analysis. We are actually using the open source Escalate machine learning tools for developing the same. And we are also using IBM Watson natural language classifier for our expert system. So we integrated the cuff analyzer with the triple dialogue model. Manish is going to cover the details on that. And I am very happy to say that NIMS Nizam Institute of Medical Sciences, Hyderabad, the respiratory medicine organization is actually working with us. They are helping us in more data collection. They are also helping us in doing the clinical evaluation. Actually, with one of their students, we recently just started the clinical evaluation of our tool. And they are also interested in doing the earlier adaptation once the model is completely up and running. Dr. Paramjyoti and Dr. Bhaskar from NIMS are working with us. They definitely see cuff analysis will help in differentiated diagnosis of common respiratory diseases. And this is, as per their thing, this is completely being ignored as on today. So, as I mentioned, currently the clinical evaluation of our prototype is in progress at NIMS Institute. And subsequent to this, we also have a startup team which is actually going to take the whole activity forward. I mean, essentially based on the clinical analysis, the team will address all the functional, user and system related issues and develop a field deployable solution, which we call it as a beta type. And then deploy the tool on selected public health centers and community health centers. Actually, last time Bengaluru High Spirit, when we interacted with them, they suggested us to touch in base with Sunita, who is also working with the Andhra Pradesh community health and public health centers. So I actually touched base with her and I did demonstrate the prototype to her, and she is going to help us in evaluating the deployability with the PHCs and the CHCs. So you can also help us. You mentioned AP. There is a lot of because I don't know whether you are working with Sunita. Sunita, you are on the same team. Sunita from EMC. Maybe I'll be in touch with you or something like that. Because right now we are doing a clinical evaluation of our stock analysis module with the NIMS respiratory. We also received the United Inventors Association of the USA Certificate on Innovation and Excellence when we presented this idea at Seoul International Innovation Fair in 2016.
First of all, I would like to thank Narendra Ahuja sir and mentors. They are tremendously helping us. Ours is only least funding instead of all the groups. Even though we have very less fund, from the day one onwards, Narendra Ahuja sir gave a lot of tremendous support, and our funding is increased initially from 5 lakhs to 18 lakhs. So I thank Ahuja sir for supporting us. Even though we are not getting a lot of fund from this project, our institute has raised a lot. Many of our students as well as faculty are working for this project. Not only this project, we are having another project, water project also we are having one project. In that also our team is contributing a lot. So that also we are going for startup. This also we are going for startup. I am happy for that. Thank you sir for giving such opportunity. And with that, with your support, we have conducted one international conference also at our institute. As a chair, I am the chair for that conference. We got tremendous support from the publications. Nearly 600 papers we got. Out of that, 77 papers we have sent to IEEE Exposure. All those papers have been accepted. Within 1 month, they will be published in IEEE Explorer Digital Library. And we have, from this project, we have published 8 papers. I said that all those are not at high rate papers, but initially we don't have that much awareness. Now we have learned many things from this meeting with all these members. That is good learning for us. So we hope still we go on. Coming to curricular impact, we have included the speech processing and IoT in both the UG as well as PG courses. We have included the established IoT lab, especially for healthcare domain, to do all these projects. So already Narayan Professor mentioned about we have presented our project at NASCOM, demonstrated our prototype, and we are presently working with 3 hospitals. Sai Siddhartha Chest Hospital, Shrestha Pulmonology Care Center, Respiratory Medicine Department NIMS, and up to now we have collected 200 samples from various already known patients. We are collecting data. So based on that one, we are deciding whether whatever analysis we have done, we are able to classify whether it is correct or not. So already clinically validated data we are testing. So now up to now, whatever we have developed, all those things we have implemented on mobile app. Now we have to make that mobile app into prototype.
So I think there is a good learning from your team to the earlier team of Human Science and other people, who were talking about.
There is a challenge of accessing clinical data, but you are able to solve that. Maybe I think there should be an inter-project learning coordination. You should tell the Human Science project or the remote health project how to go, get in touch with these 3 hospitals, and also you went into NASCOM product conclave. That's a very good start. The sense of entrepreneurship is higher in this team, which is seen compared to the other teams.
Actually, one other interesting thing what happened is the news Dr. Paramjyoti is showing a lot of interest. Basically, this is also learning for us. There is something called clinical evaluation and there is something called test evaluation. So the PFT test and spectrometer, all these come under the test evaluation. Now the cough signal analysis comes under the clinical evaluation. As on today, their analysis of clinical evaluation is almost negligible. Okay, so he says sound analysis is really very interesting and actually they are assigning one student to work with us from this.
Because you can talk with the other remote health project, which is also taking the spirometry.
Yeah.
It can be
Correct, yeah, there are a lot of relation inside.
they can leverage your contacts and you can leverage that as a portfolio into your research.
And another interesting thing what happened was at Sai Siddharth Hospital, we actually placed the audio recorder for the entire night and attaching it to a person who is suffering with pneumonia. And we could collect 20 minutes of cough sample from that 8-hour data. And we could actually tell what was the frequency of cough and how much of that helped and how much of that was dry and so on. And Dr. Kiran was very appreciative of that. Thank you. I will be in touch.
As it is, as I mentioned earlier, this is one project where the proposed title or the proposed aim was, the proposed aim was not really met, and we know that it cannot be met. It does not have the traction that is required. The clinical data we were just discussing what about the clinical data security and all of that issue, and because of that we were not able to collect conversational data between doctor and patient, which was the primary model for this virtual assistant and for their models. So basically both the components here moved on into different directions, but we do have this one complete prototype which serves as our proof concept in terms of having a complete virtual assistant, which is granted doing diagnosis at this time. In the last presentation we mentioned, we are not trying to change that anymore. Even though we know that we should not be diagnosing at this point, we are concentrating more on the technology part. Developing good dialogue models, developing good analysis systems, and going for better ASR, speech recognition. The challenges in this project were initially, when it was not healthcare, when it was not something else, it was that to develop ASR systems which can reside on a mobile, not on sitting on a cloud server somewhere, but on a mobile which can do a limited domain or a large domain automatic speech recognition without any requirement of network, because we do not have low latency, high bandwidth network availability in most parts of the country. The advantage, the highlights of this all of our efforts in speech recognition, particularly we have done a lot of adaptation and compression of the speech recognition module such that a smaller module can have higher recognition accuracy for a particular domain, even with noisy data. And that also means that it works even for post-mixed content, meaning you can mix Hindi and English in the same sentence and it would be able to identify. This is a highly parallelizable architecture. There can be multiple ASRs running on multiple languages, so there can be an ensemble system at the back end, but we do not really use that. We are not really using multiple encoders for multiple languages right now. We have a combined model for automatic speech recognition for Hindi, Telugu and English on the same model. The model itself is trained. One of the biggest difficulties that we found earlier on was that deep learning models, porting of deep learning models to mobile devices was very hard. Getting them to work on that on the resource constrained environment is hard. So one of the earliest efforts for us was to convert decoders which can take a pre-trained compressed compressed and pruned model for recognition on mobile devices. So the models, acoustic and language models trained by Kali on a high-performance server are then compressed and pruned and then integrated as a base model for the mobile device to support multilingual ASR. Of course, the model itself is trained on combination of data from various different languages with semantic similarity, eventually leading up to a monolingual, a monomodal network which can support multilingual code mixed input. A lot of work went into finding out the best mechanisms for achieving this model, because as expected, in a noisy environment, with a real world environment, there would be a number of errors generated just because of the ambient noises. So what we did was, instead of going for phonemic and syllabic approaches, we went for articulatory gesture approach. The student who had worked on this particular part has graduated, but what we found is that most of the languages, at least when spoken by language of, let's say, Indian native family, would have the same articulatory gesture. We are not really trying to speak in an American gesture. Even if we try, we are borrowing articulatory gesture vocabulary from our Indian native tongue. That means if we are, instead of converting from signal to phoneme to grapheme, if we are going for articulatory gesture to phoneme to grapheme, we would be able to harness the same vocabulary for the input source, irrespective of what language we are speaking in. And that was the work that was presented in ICAS last year, and was also submitted in the speech as a larger part of a larger. This was the first insight, and the manifold learning was another. What we have is a raw speech has a feature extraction in a lower dimensional manifold space based on articulatory gestures. So what we eventually get is a combined or a common space for articulatory representation of multiple language speech. This representation is then fed to a convolutional neural network autoencoder, and the bottleneck is what gives us a lower dimensional representation for individual speech signals. This approach has given us the state-of-the-art results for speech recognition in a constrained domain. There are many common methods, for example, MFCC baseline or PCA for dimensionality reduction for MFCC baseline, so on and so forth. ISOMAP was the approach that was beating our approaches earlier. Though standard autoencoder outperforms ISOMAP in some cases, for certain parts. But we find that convolutional autoencoders outperform this significantly, and also with, though the number of parameters being trained is significantly higher than ISOMAP or standard autoencoder, what we find is the final model being generated is very small, because we can control the bottleneck. So we can compromise on accuracy slightly, but get a significant reduction in size, and that is a bottleneck that we. In autoencoder, compression factor again is dependent on what bottleneck you choose. Yeah. But even this autoencoder the one we have mentioned here is the best case scenario for the autoencoders in all compression parameters, all sizes, different sizes that we have tried. What we found that the convolution autoencoder for a lower size even gives equivalent or better accuracy than standard. Training parameters is a different issue altogether. That is why we require a high performance server to train them. And it takes a significantly larger amount of time as compared to standard network. But since we are not pushing that requirement onto the mobile devices, we are not really worried about that. These ensemble methods were tested for voice activated decoding for Android devices. Many methods were tried, but there was no significant increase in accuracy. In fact, the false activation was a bigger problem. The significance relevance to the project for this line of work of going for compressing the models or porting quality into mobile devices was that we wanted to have no network dependence, that's one. And second, we wanted to have multiple language models. There was a space constraint, and that forced us to learn one single model for all of them. It worked out pretty well, though individual model, let's say for English, would perform much better than this combined model because it is getting affected by the articulative vocabulary. For an Indian speaker, that may not be. Beyond this case, beyond the scope of the project is where the advantages really show. The fact that we have a single model, not an ensemble, and not a classifier model which says, which first detects which the word is in which language and then tries to decode it. Now we can have one combined model which can decode the whole sentence without really worrying about switching models. That means a single model would be able to handle what we call code mixed content, which is the common urban Indian native language usage. मैं dinner के लिए जा रहा हूँ और one such example. Dinner is an English word, or it can be any more complex, more rarer English word, and it would work. It should work. And this is the advantage that is made it a bit interesting for many of our industry partners. Till this point, that was a few hours ago, I had written a meeting back. I just 15 minutes ago, just before the presentation, got information. We are in communication with Axis Bank. They have just confirmed us a time for demo of this system for their transaction based, for their Indian language transaction model. This is just 15 minutes. One of the things that we really understood is that with our experience with medical domain, we found that lacking data we could not do much. We could not do anything at all. Whatever data we had collected in-house was mostly in a very, very controlled environment. Even if we are sitting outside the room and with some ambient noise, that cannot compare with a railway station or a live work environment. So we found that collecting real world data is the most important thing now. However this data comes by, we do not really mind. So what we are hoping for is developing partnerships with whichever partners who can give us data in return for the technology. We are not really looking to earn from it. Rather, we want to collect real life data sets, which they can, if they can give freely after sanitization, we are okay with that. So largely with whatever partners we are talking in these terms. That we would want to use their data and eventually release that data for the research work. That means the dialogue model is the biggest achievement. Till last evaluation, we had presented a very simplistic dialogue model, but from the beginning, the idea was to have a generic domain-independent, language-independent dialogue model. Basically, a state system which can be deterministic whenever required, but which can be probabilistic and non-deterministic as well. So what we have is a scalable and portable architecture, which still is a very, as far as a flowchart goes, it's a very simple flowchart, but it can grow into a very large and very scalable architecture. In the last 6 months, we have integrated top modeling to dialogue modeling.
It's like 20 minutes. Yeah, 5 minutes, wonderful.
This model can, one of the advantages of this model is we have associated states and keywords, and therefore adapting to a new language or to a new scenario is very straightforward. That is why we are currently hosting 6 interns from Fly Dubai. They are interning at Fly Dubai, hosted at Flight Hyderabad, developing flight booking bot with this model. Their internship was of 2 months. Within 15 days, the transaction model was complete. Now they are just working on UPI. This is I'm just demonstrating the scalability of the model that has been developed. And of course, Pratyusha, the one who has developed this dialogue model, is mentoring those interns. So. And again, since it is coming from our virtual assistant, the model by definition supports code mixing. The input could be coming in multiple languages. That is another interest from Fly Dubai, particularly because they deal with primarily 3 languages: Arabic vocabulary, multiple Arabic dialects, English, and Russian. Like I said, the dialogue model itself looks very simplistic. You are in some state and you have a list of states that you can go to, and it's just validation of the hypothesis, ASR hypothesis that checks whether you want to prompt the user to repeat or to take a decision of going into another state. So the reason for keeping this flow very simple is the decision can be, this decision module is a plug and play. There can be multiple different kinds of decision modules which can plug and play at any point. And the same decision modules can be repeated or reused later on. If it is already there, if the decision is to get back to the same state, then it will continue in that loop. Otherwise, it will execute the entry, and then entry, execute, and recognition is the process that is repeatedly followed, with each edge between different states being an entry, execute, recognition order. This is something that we had seen last time. Oddly, this time I think I repeated now, but I missed the code mixed image here. What we have done further in the last 6 months, the mandate was to integrate with the COF module. Now we have an integrated and larger COF dialog model where, while giving symptoms, if the person mentions that he has cough, then we go to their COF module, get their analysis, and that becomes part of our decision process. The further decision is based on the analysis sent by their COF module. This was evaluated in-house, has been submitted to IGC NLP this year, July. We have seen that most of the, and this is part of the report that we submitted, in many cases, when errors happen, even then the system is robust enough, because there are verification steps after every input that is being received. So if a person would have to commit 2 mistakes for a mistake to register. Do you have cough? You had not started cough and it recognizes do you have cough, and then in verification you say yes. So a person would have to make 2 mistakes in that scenario. We have also integrated classification of the skin condition. This was already a part of it, part of the system. We have not yet used it in a decision process. So it's not. We can go there, but we are not using this information yet. So this would be the work in the coming month. Again, since we were using deep neural networks for ASR and we were getting very good, we had all the libraries already for that task. We have done image recognition as well on deep neural networks. We have also collected a large amount of data, which is 560 diseases, 63 symptoms. This was from this we have already mentioned. This was from human disease ontology. Currently, we are working with a subset of 10 diseases, 20 diseases. And we have, in the process of developing the ASR for Indian languages, we collected around 35 hours of Telugu speech data with annotation and field. But even with this additional data, the verdict is the same. We need real life data to do anything. We cannot really do controlled environment recordings and gain anything from it. Gautam, there were 3 PhD students associated with us. Gautam has already defended his PhD thesis and currently is a postdoc at Apple now. This condition has changed. Anand would be submitting this month, is on leave. The 3rd PhD student is currently a postdoc at Phoenixia in Czech Republic, working with European speech recognition, so he has not been with us for a year. We have had some very good publications, very well recognized publications through this project. Some of them were for semantic similarity, question answering, dialogue act tagging, so on and so forth. We have introduced a course called Topics in Discourse. Dr. Mamati is teaching that course, and the work that both our students are producers here. The work that both producers are doing is being used for this course as well. We were interacting with NCSoft and SALI Technologies for technology transfer. This did not work out, but currently we are working with Flytheby and Computer Associates. Computer Associates work has just started there also. The statement of work is not finalized, but the idea is again to have a dialogue engine. But this dialogue engine would largely be monolingual. So the code mixing is not the important part here, the state-based dialogue modeling is important. Last year and this year we conducted international advanced upper school for natural language processing, and we introduced speech recognition, dialogue modeling and discourse processing tracks. We have had a number of tier 1 publications and a large number of tier 2, tier 3 publications. In the last 6 months we have submitted papers, but we have not, there are no additions as such, so it's basically what you've seen in January. That's pretty much it. I have a small demo which I do not know whether it will work or not. Full from my side.
Fever.
Sir, there is volume here.
Yes. Click on bracket to give a cough sample.
Just one
Say
second.
runny nose. Please tell your symptoms. Cough. Please tell if you have any other symptoms. Fever. Did you say cough? Yes. Yes. Click on bracket to give a cough sample. Did you say runny nose?
That's the cough sample.
Yes.
Are you also collecting the runny nose sample?
Symptoms to start diagnosis. There are 1 diseases found matching your symptoms.
Unfortunately, you don't have to
Pharyngitis.
discuss for it.
So this is runny nose, not runny nose.
Okay. Most probable diagnosis is pharyngitis. Do you want to know more
That
about
is how
it?
it was mentioned in the
Yes.
funnily enough.
Okay, here it is. Thank
We
you.
have to trust the doctors on whatever medical sources we have. This is exactly how it was in the ontology. So the disease ontology that we have borrowed the symptoms.
form of the output.
No, for the output we would still follow. This model, though the video is for one language, the model has a base language, base interaction language that basically sets the response language. So it can respond in Hindi, English, or Telugu. Here it was reading in English. Even if I mix two languages, the response would be. Not necessarily. I'll put it in this perspective. It would need to have a semantic equivalence with something in the target language. If it does not have, then of course I would have to transliterate it. We are not doing translation. What we are doing is semantic similarity. What we are doing is bringing languages in multiple words, words in multiple languages into the same vector space and bringing semantically similar words closer. So this is multilingual word embedding. So that means that if you say fever and bukhar, they are close by in the vector space. So while generating, I would pick up the nearest word from that English word, nearest Hindi word from that vector space, pull it. Given in a data, it would have to be bukhar or jwar or something. Any other?
Not a question, but a suggestion is, so we know this project is running in both in Melbourne as well as, as funded by Gates Foundation. There is a good link for AIDS. There is a foundation which supports this AIDS victims over call, that they should be taking medicines and there is a psychological counseling that happens over phone. Now, AIDS victims are also, or HIV positive patients are also highly vulnerable to have tuberculosis. So tuberculosis improvement is also a secondary sign for response to HIV medicines. So these call centers there is a specific task to track for whether the TB is also getting improved or not. So maybe I think your stuff can get a very nice plugin because this is mostly voice based. And again, these guys are EMRI, Apollo, and Pyramid. So these are the three providers on the ground, and they use voice as a communication tool. So you can plug in that because the person is specific with love. So you are providing value-added services on top of it. So maybe you should start saying, okay, I want to collaborate. I want to test initially. Yes, this can provide some improvement of love for tuberculosis patients. And NACO funding is very huge, so you don't have to worry about the funding. Now that they are looking for more technologies and you can provide them. Second stuff is NHS is on the way of adopting chatbot-based primary care. The company is called Your.MD. Your.MD.
YO?
Yeah, Your.MD. So
Your.MD.
So Your.MD is the company, and this is funded very loosely now. So they are now still in the startup mode, so they would be, I think, eager to collaborate. To get resistance, you will reach out to me. Write to them directly, and they will respond to you. Can I plug in my module? It's a chatbot, so you can key in your symptoms. So they have solved the problem of getting the heuristics of medical ontology. Whatever way you can do, there is a very solid NLP engine which runs behind your autonomy. You can key in your additional features. So that might help your autonomy come to India. So these two can be your natural pathway.
Thank you.
So I have one question. So you mentioned that we cannot run the deep neural networks on the phone.
I think not really. It's not that we cannot run it. It's that for multilingual recognition, having three models or running three threads with such heavy models put a lot of requirements on the device, which is well not. You do not want to render the device useless while the person is using that app.
Right. So is it possible that you put that data, I mean you transfer the data to some cloud, run your models of prediction over there, and then again put that?
Well, like I said, that is the tradition.
Right.
One of us will have to switch off that is the traditional model, right? So the Google Voice, S Voice, everyone is doing the same thing. You record, vectorize, send the vector, or you send the vector, whatever. Our problem is that this model requires reliable, high bandwidth, low latency. I have a 4G phone, and half the time I'm on Edge network, not even GPRS, Edge, lower than 2G. So, having the name LTE even in Hyderabad or even anywhere does not really make much of a difference. Most of the people cannot use it either financially or because the coverage is not really that good, and forget semi-urban or rural areas. That is the primary reason for taking this task, which is seemingly unimportant in the research community, because LTE is a sort of considered a given now, but that is not the case for most of the underdeveloped.
So is it not possible for you to only record the new sessions and transmit them at whatever speed later on, but in the meantime, the training is happening in the background in cloud, but your trained network is being input with your current dialogue and it responds to that.
So having this or collecting this feedback wherever and whenever possible. So the last few sessions, we may not want to keep multiple sessions recorded. Last few sessions we can keep, and whenever he has given the feedback, yes or no, whatever corrections he has done. So that we can figure out. When our system is making errors, we can collect that information that can be pushed, and later on the model can be pushed back. The better trained model can be pushed back. That is an engineering issue that we are aware of for the last 1.5 years. We have not really worked towards it. Now is a good time to actually do it because the ASR part is with that.
And the gesture is not really, or at least if you are referring to voice gestures, which you are not, you are referring to visual gestures.
We were referring to visual gesture.
Yeah. So
And
that is
visual gesture converted into speech recognition because we had gone into, for 1.5 years, we were into visual gesture recognition as an ASL-ISL combination. And we were collecting data, but that process was significantly slow. And it was decided that we change that to have image processing as part of the engine. Now, bites, cuts, lacerations, and burns, these were the 4 things that we were considering that we can use for image processing. Can you identify this bump on my skin? And we are getting good accuracy for that. It is just that it's not really a very detailed, it cannot be a detailed dialogue model because what I said was pretty much it. Can you identify this? It is most likely this, that's it. So the identification accuracy we are getting.
Sign was asking you a question about not doing the algorithms, assuming that a high-speed data link will be available and a high-performance infrastructure comes to it. I think your answer was that today, in Gachibowli, the data rates that you have access to are getting low. And your assumption is that elsewhere in the country is not going to be any better. My question to you, can I summarize it?
Okay. Yes.
My question to you is, let's make the assumption that high-speed access would be available, high-performance computing infrastructure would be available. Would you redo this differently?
In that case, in the last feedback workshop, we had this discussion. In that case, we would still want to have this model. When we, if you are assuming that, we are also assuming that 4 GB RAM and whatever.
I sense that because of the limited amount of capability available here, you're making certain compromises in the recognition part.
We are ready to make those compromises. And every group is doing that. Every recognizer, let's say Cortana ASR, also makes those compromises. The first result you get is likely to be wrong, and then suddenly it corrects itself. That is when it has received a response from the server. So yes, there is a
My sense is that in the coming months, the situation is going to change very soon. So if you're designing something, you should keep this in mind that 1 year down the road, 2 years down the road, this assumption is not going to value.
First part of that. The first part of it, focusing on phonemes, definitely should not you would not change the conversion to phoneme.
Right.
That's an important.
Another speech recognition I
So we should stick to articulatory gesture.
Yeah.
Yeah, but about this concern, there is another. I would argue that if the technology is due to come to the remotest part of MP or UP in the next 5 years, but some person there still has a mobile phone, and likely to be something 6,000, under 6,000 or 6,000 range. He has a smartphone. Why do I keep the technology away from him for another 5 years? And if he has this app, he has something.
The overall point was, whatever we do, we must anticipate the changes that will happen in the coming months.
Yeah.
That's the point.
A little bit of a digression, but more of a management or innovation management stuff compared to technology. So somewhere, this is a common stuff, especially with engineers, is if you're solving something, it has to be solved for the entire 100% of the population. And it's never true in that way. It was never for iPhone, it was never for Windows, it was never for, let's say, Pentium, it was never for any of those big innovations. You have to look for one thing. Is it for a sizable population? There's a big difference between are you solving all the use cases or are you solving a majority use case? If you're solving a majority use case, even let's say your use case is people who are into the right networks, having a smartphone which is of minimum 2 GB RAM or 4 GB RAM. If that comes to 200 million population, that's a very big population. So I think you have to uncondition that in your brain that somewhere, I think this is for everybody, not only for everybody, is it's not that you have to solve all the problem at once, then only you can go to make the technology transfer. If you have a sizable population which is ready to key in some money, which is making a good enough, base for a business to be sustainable, that's a good enough, So don't self-criticize yourself into that part that, you have to really lift the mountain, then only you are successful.
So,
you can find the right, use case, the right business model, you are there.
With this feedback, I'll rephrase it a bit. I do not really want to solve this problem and I do not think that they would never get a network forever. That's a different issue. We get to learn a lot from this exercise. We get to learn, we get to learn a lot, we get to build better systems which are on board. Worst case scenario is on board. The the highest or the lowest latency, highest response time systems are on board, even with the fastest networks. If that is giving a good accuracy from the beginning, we should pursue that. And this is the extreme scenario of that. So pushing deep learning models, pushing better compressed models onto handheld devices is a good idea, even when we have every infrastructure available. I think, that would be my responsibility.
So there are two things that are being said. On the one hand, I think, on the one hand, there is the urge to excel, to do, everything there, because it drives you to innovate. You force yourself to find ways around the problem and work with the cell phone. The other thing that is from the panel is that while you're doing that, you could also be maximizing the outreach of what you have by doing this. So it's a question of where your cycles go and where your students or your neighbors' cycles go. Everybody may have their own preferences. They might be pushing that to the public while you are at the same time trying to push everything onto the phone. And both can go together with the phase difference.
Absolutely. I would say that should be the way to go. You have the infrastructure available, you have access to the infrastructure, you go for it. And I think there's also this thing that it is available, that part is available.
You could try with Amazon Voice Lab. Amazon Voice Lab.
We have it, not for India.
Yes, that's open. You just have to register, it's free. And you say, okay, I am providing my course set to be integrated with Alexa for, cup analysis or this, language analysis. And this is just absolutely free. So I think
They are using for cup, they are using Amazon for.
I think he's talking about Amazon Echo that
yeah, Amazon Echo has opened up a open API for people
Alexa.
like you.
Alexa.
It's called Alexa Voice Lab. You can directly get integrated with their speech engine and provide this as this module. This is for example analysis module or something other. You choose your own use case. So it is going to be validated, and if it is appropriate, I think you might be part of the engine also. So right. These are innovative ways of you don't have to pay anybody. You just need to have internet and then you test yourself. So.
Do they get anything back?
Yeah. So if they are selected, they might be part of the Amazon Accelerator Lab. So.
Yeah, any questions from the audience?
Now, when there's some validation you were showing. Okay, so what were the false positive and the false negative rate? Roughly did you calculate? And what was the area that occurred?
I cannot recall off the top of my head.
Roughly, is it 75% plus? Then it's okay.
I would, can I get back to you in 15
Sure.
minutes? This should be, the student is not here, my area is not speech recognition. So, yeah, the student is not here, his thesis here, I'll just go through it.
So the true positive, true negative should be 75% onwards.
I'll check.
Any more questions from the audience? Students? We have a 10 minutes break now for tea, and after that we will have two panel discussions from 5. And two panel discussions actually combined into one. everyone, and then we'll have the last session. Thank you.
So what panel systems are common? No, I don't understand what is combined. Am I still involved or no?
Yes.
You still? I've harassed you enough now.